Sure.
Yeah. Mm-hmm.
So this was done in 2018. That's when I joined Air Lab actually. It started off as the idea as having something that is very light, very elegant, that could support as a furniture scale function. Because at the start we did prevalence scale for open house, and now we wanted to do something that is functional as an object itself. So there are two main components, which is the space frame and then the tabletop. And then you'll be using the same concept that we did for V-mesh. So it started off as okay. So because the structure itself that we did for open house is it doesn't carry much of a weight. So this is the second project that we wanted to test, like how much load it can actually carry with elegant lightweight materials. So for the tabletop, it's weigh about like 200 kg itself, but the component of all the 3D printed nodes for this table is about less than 10 kg.
Yes.
Yeah. So it is made out of 91 nodes. So it's very intricate, and it makes out of 3 modular system that we actually integrated for the lake system. So each has its own. The challenge for this is how we can actually print this out of metal parts, and because to transform from a nylon material to a metal printing technology is actually 2 different printing methods. So the challenge is always about the supporting materials that we need to encompass. So a typical sintering materials requires a lot of supporting base. So we tested a few and we found a binder jetting printing technology that uses powder bed as a supporting material, which can be removed easily. So in this case, the nodes is a shell system with threaded ends, with a left threaded and right threaded system. Because when you have a rod and you have 2 ends, so one side is clockwise and the other side is anti-clockwise to ensure that you can thread in a single rotation direction. So the challenge for this, because it's in a triangulation form, and to build upon one another, is always the change of distance that create difficulties when you have enclosed system loop. So as we thread, the challenge gets tougher because there's accumulation of tolerance issue. However, we managed to resolve by force, and there's only so much maneuver that you can do for metal parts material, because I mean the stiffness and all, as compared to the first V-mesh that we have, where we were using aluminum tube that has more flexibility in terms of deformation in that aspect.
So maybe you might be wondering, why are we interested in making this table, right? It's like, well, we do architecture, why a table? So, sometimes the ideas need to be tested at a smaller scale. So when you have a new idea, like I want this kind of system, of this kind of network of bars and nodes to be developed, then you can use smaller scale things. So the table in this case becomes a kind of a nice test bed to allow us to develop the system, because what we're doing here is not to use off-the-rack components. Let's say we're gonna build this table with whatever things that we know that work. We are actually, let's say, developing a new system. That's what we do in SUTD. We want to actually develop new ideas, new way of building, and that's why using 3D printing and technology is the way for us to go ahead. And this actually showed, as you see in the picture here, that at some point it was difficult to put it together. So sometimes we draw things and they say, wow, it looks so nice, and it looks very, very, very doable. But then when you are actually hands-on and you work with the real materials, you feel like, oh, it doesn't fit, or we need to change the strategy. So that's the way we do things here as well. We test the ideas by doing them, but actually by executing them. And then that's the only way that allows us to really push the ideas forward and to develop our systems.
So these are the discovery that, I mean, the problems that we face along the way. So this table is only supported by 3 points is about a coin size,
Mhm.
adequately set in our demand D lab.
Correct. You can actually, if you're allowed, I think you should. In building 1, level 6, this table is
7.
Sorry, level 7, level
yeah.
7, demand D lab. The table is there, so you can actually see the actual table functioning. So yeah.
Yeah, so we did I mean, on top of the table, we did a load test to ensure that the structural component and in the functional component of 3D parts is working well beyond just modeling or representation scale. Yeah.
Mhm.
So the idea of like fluidity and continuous connections between nodes and bars are being actually articulated here. So with this study, I mean, being firsthand to actually build it and construct it with the lesson learned, we move on to a larger scale to put it in Gardens by the Bay in 2019. So this project actually, I mean, it runs over a period of 2 years from design, conceptualization stage, design, and all the way to actually construction. So the concept of this is a lantern. It was intended for Mid-Autumn Festival. So we wanted to add a little gem in the garden itself. Yeah.
So we wanted to test at a larger scale. I mean, we work at the table at the pavilion, and now we wanted to do a pavilion that is actually functional, that people can go in, and it's a build project, right? In a real space, in a space that people can access and enjoy, right? So we tested a few ideas here, like how to look at certain views, how to create an access ramp, how to create a cantilever. So there are many things that we wanted to test in this project. So in the site, you can see here the location of the pavilion is this white dot you have seen there. So these are the views to the main landmarks that you can see from there, right? So that defines the view, defines the geometry of the pavilion itself. So we wanted to look at the roof of Marina Bay Sands, quite iconic. We wanted to look at the Dragonfly River, and we also wanted to look at the Future of Us dome that actually Thomas will explain later. So we're actually quite close to the dome. And then we actually, those vectors, those views are defining the shape of the pavilion itself. So you can see here the floor plan, how it's inserted in the site, and you can see also the ramp that leads to that pavilion. So we developed a system to subdivide the geometry into tetrahedrons. So basically, it's like pyramids. So all of these pyramids together make the shape of the pavilion. And then we integrate structural calculations. So it's not just look nice, it's actually performs. We wanted to actually develop a system that reduce the use of material. So we maximize the performance of the components. So the position of the nodes and how the nodes are arranged and the geometry itself is maximized, is actually biased to achieve that.
So so the nodes is made out of, I mean, you see all the directions. These are the vectors of the bars. And with the structural analysis and the data that it generates, it informs us about the load it carries on each bars, be it compression or tension. So this information will indicate the size of the bars that we have. So under compression, you will have a larger bar, and tension will be a thinner bar. So with this, I mean, instead of using a singular size, we wanted to test something that is more dynamic based on the performance of the load requirement.
So maybe you look at the buildings around, you see columns, right? Like big columns, and you see beams, right? Like they're quite big. And typically you see distinction between a column and a beam. There are different things, right? For us in this system, there's no such distinction. The bars could run in different directions, in inclined direction, horizontal, vertical, and they basically are treated equally. So it's a way to make it more, isotropic. The system is not divided into elements. Okay, I have a column, the column needs to be vertical, needs to be thick, and the beam needs to span. It's a different way of thinking, right? This kind of network. So that's why we needed to develop all the previous projects to really implement that in a real construction. And this is one of the nodes. It's printed in stainless steel. This is the prototype one I'm holding in my hand. This is in nylon. So maybe also you can pass it. This is the first prototype that we did. And those nodes are structurally driven, and they can connect the bars to form the pavilion. And this is the family of them, total of 54 nodes. So also one of the things here is to identify the nodes. We label them so we can recognize which one goes where. It's kind of assembling a jigsaw puzzle in 3D is quite fun. Well, it takes some time, but it was really interesting process. So maybe you can explain a bit of like the connection system.
So the connection system is made out of threading, like normal bolt and nuts. So instead of having separate components that build upon the 3D printer nodes, we wanted to tap on the technology of 3D printing accuracies and tolerance. So we embedded the threaded system. That means we pre-3D printed the threaded system into it and actually integrated the bolts within the bars, so that when we actually assemble, we just need a hex key and screw the components in to to simplify the assembly process. So we did a test in campus, just a 1/3 pavilion. This is a full scale to test it out, the assembly sequence, and all these are done by students.
Yep. So it was great that we could put this together in 2 days. I mean, it's a still a structure, right? It's like something that performs. It's a permanent structure, and then it can be done with just hex keys and just us. I mean, researchers, professors, students. It's relatively accessible to everyone, right? It's like kind of the IKEA of stainless steel, right? It would be a way to put it in a simplified way, right? So this was done in SUTD downstairs, just in front of the cafe place that we have passed by today. And then once we finished, we used the 3D scanner to actually to digitize and to get a 3D model of the thing we just built, in order to check that everything was according to the geometry that we wanted to make. So we have a 3D model here by using a 3D scanner. So all these tools, we use them here in SUTD at the studios, when we research, when we work with you guys in different projects, we have access to this technology. So here we move into the construction stage. So this is how we actually connect the box. So the assembly of the pavilion was done as well by our team. So we were the ones going to the sites and using, all the tools and put it together. So it was quite fun, actually.
It's fulfilling. I mean, seeing from things that you design from computer screen all the way to actually building it and actually being part of it. I think the satisfaction is definitely there. Like that I don't see it in any other fields. In this case.
Yes, when you close the loop, right? You start drawing the first lines, and then you see how those early intuitions, like you had, or the ideas, are turned into a space, into they're fabricated. They come together perfectly, and then you have a piece designed by your team. It's amazing. So that was a great fulfilling experience for each of us, because it has been many years of working together, many people in the lab, many students involved, and then it's the outcome of it, right?
And it's not just the end product, it's actually a relationship that you build up throughout the journey itself.
So that feeling is very difficult to explain. You only can feel it when you get there. Architecture is very dense, the way that you experience things, especially when you build something, is when you actually understand all the work you have put together to arrive to that point, which is building and to open it to the public, right? To use it, right?
The smile that they put on their face, I think that's amazing.
So this pavilion was also conceived to be wrapped by plants. So it has a very ethereal mesh. So the idea is that in the future, it can grow plants and create a complete green structure. We covered the structure with recycled nylon fishing nets. So it was way of wrapping the structure with 2 layers of that. So it creates nice nuanced light inside. It's breathable. It's actually open air. And you can see here that the views that were actually determined by the vectors that I showed at the beginning are open. So the rest is covered by this mesh. So we actually frame the views by removing the net from those parts. So this is the atmosphere inside, quite ethereal, quite breezy. We talk about the relation between, humans and nature, and be inside but very close to the open spaces. It's a pavilion you can touch, and still there's some response. It's quite elastic, so it's still not super solid in such way. So these are views of the pavilion that still in Gardens by the Bay. So it will be at least for a year. So till end of this year, is still open for you guys to go. At night, it shows these nuances. We have LED lights, so it changes at night with different colors, and the pavilion can be accessed anytime. So you can. It's a space just to contemplate nature, to chill down. So so we talk about sometimes about function of things, like what is this pavilion for? Are you designing it for what? What is happening inside? And architecture can be the support of unforeseen activities, or just space for to have any to be interpreted by people in different ways. So we don't need to have always a program, a brief, and then to say, well, we're gonna make offices for 20 people. Could be quite open-ended, and that was also part of our job here. Like we actually presented this idea to Gardens by the Bay, so it's more self-initiated project. They didn't know that they wanted this. So basically, we came up with the whole brief, with the whole system. So we try also in SUTD to push ideas that come from anyone. I mean, it could be at the professor level, it could be at the student level. We treat everyone at the same level. If it's a good idea, we support and we go ahead. And this has been a journey of almost 5 years working in this project to really make it happen, right? So develop the whole system, the structural technology that allows to print and to fabricate this pavilion, right? So it's not just the final object, but it's the whole process. And that's something that we in SUTD we push. It's not just the final outcome, but the process itself, because with this you are able to do many more things, not just one off, but many others, right? So I think that's concludes the slide. Yeah, so this is the last slide here.
Thank you, Prof Carlos and Anna, for the wonderful sharing. Must be quite memorable experience to work at Gardens to work on the MS.
Yes.
Still at Gardens by the Bay.
Yes, yes.
Yeah. So I understand the audience might have some questions, but we'll answer it later in the moderated Q&A session. But if you have any questions, please do go to the Q&A, scan this QR code, and you can put your queries there. So moving on, we shall invite Prof Thomas and Daniel to talk about their working experience with the Future of Us Pavilion. So Prof Thomas, please go ahead.
Okay, thank you very much. I'm on now, right?
Yeah.
Okay, very good. Okay, hi, my name is Thomas Schroepfer. I'm a professor of architecture and sustainable design here at SUTD. And in the following, I think is a very kind of suitable presentation following what we just saw from Carlos and his team. It's the Future of Us Pavilion. I can now, how can I control this? Can I control this?
Yeah. There's a bit of a lag.
Okay, wait. Okay, we're still figuring out here the slides. Give me a second. Okay. So the Future of Us Pavilion, I'm not going to talk as much about the technical details of the project, but more give you an account of the quite long history of the making of this project, in a way also what happened after we built this project, which was already completed in 2015. For the Future of Us exhibition, which was the capstone event for the 50th anniversary of Singapore, that I'm sure a lot of you probably remember. So the project that you see here in the slide is what the project looks like today in an aerial view. I should say the presentation here only has my name on it because at the time when I submitted, it wasn't clear who's going to accompany with me. It's Daniel who's here. Daniel has actually not worked on this project because, again, the project is a number of years old by now. But Daniel is one of my researchers, and in my lab, the Advanced Architecture Laboratory of SUTD, we also frequently work with the students. So he'll talk about this either now in presentation or maybe later also in the Q&As. Just to orientate you, so the future of us is in the bottom right corner of the slide. You see it is part of a larger ensemble of buildings by now, which wasn't the case when it was originally built. It was a different configuration. I will talk about this in some of the next slides. But it has, since its completion, it has become really a kind of a very embedded element of Gardens by the Bay that over the last couple of years has also been expanded towards Marina Bay Sands. So it's now a new entrance to Gardens by the Bay from the Bayfront MRT station. This is an aerial shot of the project. And this one is what it looks like when you step in today on a sunny morning. So I think you can probably already guess what we were interested in with this architecture. The driver was really a kind of an idea of an artificial foliage. So imagine you walk under a lush kind of tropical tree and you get this beautiful play of light and shade underneath. And of course, it's also a drop in temperature, right, that you experience. So we wanted to provide a kind of a public space environment that is also magical and almost cathedral-like experience that you have underneath. So if you haven't been at the project, of course, I encourage you to go there. It's a fully public space and it's open 24/7. This is a night shot of the project as it is today. This shot was actually just taken a few weeks ago. But let me take a few steps back and tell you what the project originally was for. I mentioned it was for the Future of Us exhibition in 2015. So here you see, this is from an article from the Straits Times, which explains the various program components that the exhibition had. And in a way, our structure was there to provide a center point. So all the circulation that you see, it's 1, 2, 3, and so on, labeled in the drawing in the middle. These are the various components: the Future Express, Theater of Generation, Symphony of the City, etc. But whenever you went from one of these domes underneath our structure to the other, you essentially walked under this experience that I just described that we were aiming for with our project. Here you see some familiar faces from the Singapore government. On the right, our students that worked on this project. So it was quite a journey, of course, for us. I mean, an opportunity to build a kind of a national landmark doesn't come along too often in architecture. So when we had that opportunity, of course, we took it. And as I mentioned before, we worked on it with kind of quite a large team of students. I think at the high time, we had about 10 students that helped with it. And it was very well received. This photograph is taken on the opening day of the exhibition in December 2015. So Prime Minister, future Prime Minister, and Lawrence Wong to the left, all very excited about our project. What they're looking at is not a model of the actual project we built, but a project that we had explored earlier. So it's a bit like what Carlos was describing in his presentation. Very often we do tests, we participate in competitions, we build models, and then they lead to a whole series of investigations. And in our case, it ultimately led to the Future of Us pavilion. The pavilion, when it was up, very quickly became a preferred kind of photo spot for people. And there was the Singapore lion was placed right in front of it, and it was beautifully lit during the Future of Us exhibition. So it was very nice for us to see how it was actually used by the public. But again, let me take a few more steps back now and tell you a little bit about the generation of this project. So I mentioned when I showed you the interior view in one of the earlier slides, that what we were interested in was this idea of a kind of artificial foliage, and in a way that translated into a structure that could be very open or could increase in density and become very close. So this is what you see in the lower part of this slide. So the basic idea is a triangulation because it is a very good thing to do for structures, and it allows you to achieve complex geometries. And you see how, as you move from the left of the structure to the right of the structure, how the density of the elements increases. And of course, the effect is that you have a more closed shell versus a more open shell on the other side. So that idea we already developed in 2013, 2014, when we participated in a competition for the Singapore Institute of Architects, which we won. That was calling for design proposals that were parametrically designed, and SUTD was fairly new, and we have technology in the name. So, you know, the parametric design competition, of course, we should win, right? And we did. But in a way, that was the starting point for all these other investigations that we did. So here you see already the translation of that idea into a model that would allow to achieve that densification of the triangle that became the primary kind of element for the structure. This is the first time we printed this in 3D. So this was the model for the Singapore Institute of Architects competition. This was for a structure in Dobie Gout Green. And in a way, every time you move, right, from the computer to the 3D model, then, you know, there's another level of investigation in the architectural exploration. And we were very lucky because at that time, someone approached us who had seen our entry for the Singapore Institute of Architects competition and said, do you want to exhibit this in the Venice Biennale? And we said, of course we want. The Venice Biennale, you might know, is one of the most important art and architecture exhibitions in the world. The Architecture Biennale happens every 2 years. Unfortunately, currently, COVID, you know, didn't prevent last year, so it'll hopefully take place this year. So it's a big international event. So what this meant for us is that we had to find a way to translate what we produce in a 3D print, where, you know, you work with a completely different material. We had to scale this up, and when you scale things up in architecture, you have to find spatially different solutions. So in our case, we did not want to 3D print a 1-to-1 or a 1-to-2 part of our idea for an enclosure, but we translated this into a system that could be produced from flat materials, in this case, sheets of aluminum. And what you see here is essentially, these are the cut sheets that were then fed into a very powerful laser cutter to produce what you see exhibited in this beautiful palazzo, this Palazzo Bembo, right next to the Rialto Bridge in Venice. So this was the location for our exhibition, and we had a small room in that beautiful palazzo, and we exhibited that model that I already showed you. And in a way, the first time we built it the way you could actually build this in an architectural scale behind it. So in a way, even though it wasn't that big, it was a very important step for us in the evolution of our ideas. So one thing leads to another. Again, in the Future of Us case, many stars aligned. The Design Singapore Council got wind of what we did in Venice, and they said, if you do it in Venice, can you do it in the National Design Center? And, you know, again, we took this as an opportunity to modify what we had learned from the previous prototype that was at that point in time still in Venice. And we explored this further, again, with the help of our students. So these are the two people in the front are students. The one on the right is a researcher from my lab. So we manufactured this at SUTD. We brought it to the National Design Center, and we assembled it in a really crazy night. We had about 12 hours to put it up before the exhibition opened. But all of this is in a way also what Carlos was describing, how we like to work with our students. We like to give you that excitement and hands-on experience of going all the way from the initial conceptual ideas all the way to the implementation of a project. So this is what the prototype wall looked like in the National Design Center. The pedestals that you see on the right, we explained the conceptual ideas, but also how you can actually manufacture a wall like this that could achieve this kind of varying density, be structurally stable, and could achieve a complex geometry as well. Again, we were very lucky. On the very last day of this exhibition, the curators for the Future of Us exhibition came. They had somehow gotten wind of what was going on there, and at that point in time, they were looking for a kind of a futuristic, idea for the Future of Us exhibition, which they felt needed a very strong architectural statement. And they came. They said, "That looks great. Can you do it within 3 months, 100 times bigger?" And we said, "Yes, okay." So quite a bold statement, but because this project was parametrically designed, even though it was for a different site originally, remember it was for Dobigout Green, in a much smaller version, we knew that the parametric model would allow a scaling up and a manipulation of the form within a very short time, and we were actually able to deliver. So what you see here is already a screenshot from the shell that we constructed in Gardens by the Bay, as you see it today. So because we had to do this in a very short time, also actually build it in a very short time, there were some adjustments to how we worked with a primary and a secondary structure. So it's not purely based on the triangulation of the elements any longer, but structurally, for those of you who have a little bit of understanding of structure, it behaves as a shell, and it is a magnificent only 20 cm in structural depth and spans about 50 meters with a height of about 16 meters, which in Singapore, I can assure you, is absolutely unheard of. So I think also structurally, it is quite an achievement. Then we had to put this up quickly. So the workers that you see here are not our students, right? These are actual construction workers that stand on these cherry picker cranes. And similar to what the previous presentation described, is a gigantic puzzle, right? Each piece here in the structure is different. There are about 10,000 elements to the Future of Us shell, and they're all labeled. So the workers, they pick them up, they put them on the cherry picker, and they move it to the location and they install it. So it is like a giant puzzle, but because every element is labeled, it's very clear where it goes, and we had no issue. We didn't have to reproduce any of the elements. So I think also in terms of construction, it shows you what technology actually is capable of these days. So after the Future of Us exhibition, all this temporary stuff was cleared out. And the question was, okay, what's next, right? Because this was originally meant as a temporary exhibition shell, meaning it was only supposed to be up there for 3 months. But it became very quickly, it became a kind of a social media spot, and people liked it. And also the Prime Minister put something on his Facebook page that he likes it a lot. And, to make the long story short, the Singapore government decided in early 2016 to make it a permanent structure that would be owned by Gardens by the Bay. So Gardens by the Bay is now officially, who owns this. And so it was there for a while, just the shell itself. Of course, we liked it that way, right? We didn't like it with all the other stuff inside. And then this happened in 2018. We had already at that point received quite a number of national and international awards for this project, but this one certainly was a big one because it is the most important design award that you can win in Singapore. So we got the Design of the Year 2018 award, and subsequently there were a whole number of events right around that fact that we got this award. So I'm just showing you some of the posters that were produced at that time. and it was everywhere, right? It was even put in the MRT trains. So as part of the kind of promotion of the projects that you know had gotten the award in 2018, and of course it was terribly exciting for us, for my team, for the students, for everybody who was involved in this project, because it was such a big success on so many levels. The project just keeps giving. So I think my last slide, I show you the list of awards and recognitions that we have received for this. This one is a more recent one, but a very important one. This is a very important international architecture award where only 2 projects from Singapore were chosen, and the Future of Us Pavilion was in fact one of them. And then Gardens by the Bay, who had become at that point the new owner of the project, they had plans for it. So as I mentioned at the very beginning of the presentation, they wanted to make this a new entrance, a new kind of bigger entrance from the Bayfront MRT station to Gardens by the Bay. So they added programs, is called Flower Symphony right now. So it's quite beautiful what they have done on the interior of some of these spaces. And I have to say, this is not designed by us. This was designed by another architect, but we're very happy because we feel it is done very respectfully to our structure. And it keeps, in a way, the original idea of the Future of Us Pavilion in place, which is, it still is this kind of central, you know, cathedral-like space in the middle of all of this. I want to share this with you. So over the years, the pavilion has been used for many things, including, you know, many of the events that Gardens by the Bay runs every year. But one that was particularly exciting is this one. About a year ago, this is an installation, or you know, a projection, to say correctly, of the Japanese artist collective Art Lab, and they call themselves ultra technologists, right? So in a way, it was a perfect match. They chose the pavilion for this projection, and I think I have a very short. This is a very short. So, I mean, we obviously are very happy, right, that this is also picked up not just by the general audience, but also by other artists and architects, that, you know, this structure actually can become an inspiration and be, in this case, a backdrop for another very beautiful piece of art. So I think I will leave it there for the moment. I wanted to share with you here the by now quite long list of awards and recognitions we have received. I highlighted already the Singapore President's Design Award, but we also received on the more the engineering end of it, and I think that's also quite important to note, the Singapore Structural Steel Excellence Award for this. So it is not just a beautiful structure that is recognized for its architectural merits, but also for its structural merits. So in a way, again, it's this very interesting symbiosis of engineering and architectural design that, of course, SUTD is exactly what this university wants to be about. So there are 2 currently, still so many years after we completed this, still 2 pending international awards that we were nominated for. The top 2, so the decision on those 2 should come out maybe by the end of the month or early next month, and I think that will probably be it. But in any case, it was a great journey. It involved many of our students. Many of them have graduated and moved on, but they come back. Unfortunately, not today because they have to work. But this excitement that Carlos spoke about, that you design something and then it becomes part of the urban landscape of your city, is of course that something that is very special to architects, and not many other professions have that. So I think I'll leave it there and hand it back to the moderator. I didn't let Daniel speak again because he didn't work on the project, but I think Daniel can address any questions, you know, regarding how we work as a lab with students, which I think would probably be interesting for you. So thank you very much.
Thank you, Prof Thomas, for the wonderful sharing. Must have been really fulfilling having Future of Us Pavilion win so many awards and your permanent thing at Gardens by the Bay. So now we shall move on to the moderated Q&A session. Just a quick reminder to submit your queries through the Google form, or you can just raise your hand over here and I'll address you directly. So are there anyone who has any questions about like the projects, or it could be about architecture and SUTD as well, or architecture in general? Yes. Okay, so since there are no questions, I'll ask Prof Carlos and Anna about the MS project. So what is perhaps the greatest obstacle that you all have faced when working on the project?
Wow. I guess coordination work was something new to me at that point of time. It's like coordinating with your own project, like coordinating with people. I think that is something, because it's something that you have some expectation of what you want to get at the end of the day, but the interpretation between your idea and how you actually understood your idea, I think that is always a challenge.
Yeah, I would say also that when you have ideas, right, and then you want to develop and to go forward with your ideas that are new and they haven't been done before, it's a big problem, right? Because people here, I mean, not just here, but in most of the places, they love innovation, but they want to have, well, it's proven that it works. So when you come up with these kind of things, these new ways of doing things, is not the standard way of construction, is actually a new system. You need to actually work 100 times more than a conventional project. So innovation doesn't have shortcuts, I would say. So when you go through this path, it's not the easiest path, but it's extremely rewarding when you get a final outcome, right? So we have been crossing hurdles like over 3 years, like, you know, from building construction authority, because it's a system that is not done in Singapore yet, so you need to get the approval from them. So from engineers, from, you know, even the landscape architects, or from everyone needs to be aligned to say, yes, we go with this. So yeah, but that's the path that we chose here. It's like, well, we know that this is gonna be hard, but with so much energy and effort, I mean, all the team has been able to put it together. So yeah, it's a I mean, now you look back and definitely it's an amazing journey. So I definitely encourage you guys, when you have ideas, just to make them work. Sometimes we face the first setback and then just give up. Oh, it shouldn't be the way to do it, right? Let's stop. But the idea is like, yeah, I mean, I really am convinced about this. And then the teamwork, just working together and help each other, you know, we can actually like achieve the goals that we, you know, ambition for.
Thank you. So there's a question for Prof Thomas. So it says that, aware that you did mention about how students can get such opportunities via capstone. So would you mind elaborating about the capstone? So a question from online. Yes.
All right. I mean, capstone, I would say is a very special thing about SUTD, right? You might know by now that, of course, we want to integrate the different disciplines that we have here at the university on many levels, and that starts with year one, where essentially you don't have to declare if you want to be an engineer or an architect. You all go through the same basic courses, and it's only at the end of year one that you split. But I would say your journey then culminates again in a joint project where you apply the things that you have learned in a way your specialty in the capstone project, which is in year 4. So capstone teams are always interdisciplinary. It depends a little bit on what exactly the project is, what the ratio is, number of architects and what kind of engineers are on the team. And then you embark on a 2-term journey with also a team of instructors. So I have been doing the capstone now for 3 years. So of course I would bring my expertise as an architecture professor into the picture. And it's just a realization that many design problems that exist in the world, they do require a multidisciplinary team. They cannot usually be resolved by architects only, by systems engineers or structural engineers or whatnot engineers only, but you always need to assemble a team. So I think it's a very unique feature, a very important step, probably the most important step in your education at SUTD, because in a way, in the academic environment, you get already a full exposure to what it might be like to work creatively on design problems in the world. And I think this is truly something that sets our graduates apart from other traditional universities in Singapore and beyond.
Yeah, thank you. So participants here, do you have any questions regarding like the architecture program in SUTD? Because we actually have a new curriculum, I think, from this year. I think, yes. So perhaps Prof Carlos will be able to share more about it as well. So if there's no questions, maybe Prof Carlos can share about the curriculum.
Mm-hmm. Yeah, this year we have new subjects that are gonna be part of the ASD curriculum. So we introduced new subjects in Term 1 and Term 3. So the first year, the foundational year, we have a subject in computational design in Term 1, which is actually quite exciting because even it's quite fundamental, but we use, actually, the nice thing is that we use the tools that, all these 2 projects here, we, in the development of them, there's a lot of computation involved, and we use a platform that is called Rhinoceros and Grasshopper. So those softwares actually are taught from the very early terms, in Term 1. So even it's in a very simple way, but you're able to experience and to use the tools that we use at a very high level. So it's nice because you actually are doing the same thing from the beginning, definitely at the very end in a higher level of complexity. So also in Term 3, we are gonna introduce an elective, which is named Spatial Design World. So that subject is, it comes 1 term earlier. It comes just before Architectural Design Studio Core 1. So that is more of a preparation for it. You are gonna learn, this is more like tool-driven, but it's not just using tools. But you're gonna learn how to 3D model, how to make renderings, how to use the 3D printers integrated with design questions. It's not just learning tools. It's like we think integrating those tools in the process here. So that subject is quite exciting. We're going to launch it in fall. So that will be the first year we're going to do it. And we are really confident that with that new subject, even the outcome of the students is going to be benefited from that a lot. So yeah, we are very excited about the new changes in the curriculum.
Thank you. So there's another question. So from our participants. So what are the jobs linked with architecture and sustainable design pillar? And is there a demand for students from architecture, especially from SUTD? Maybe this question can be to everyone from the panel, or maybe Anna, you can start first since you were alumni.
Wow. Yes. I mean, my current track is straight to academic still at this moment. So I mean, the moment I graduate, like 1 month after, I was approached by Wong. Then I was looking for myself today. Yep. And all the way to LF. I mean, I think one thing that is most sought after is actually the programming skills that actually pick it up. And I'm great that they actually upgraded the curriculum to start computation at an earlier phase. And for me, having for us, if you're gonna do an SUTD, you will be a major in science. A Bachelor of Science major in architecture. So what it means is basically with your freshman year, you have all the fundamentals being taught, which is technical skills that you will need to bring it in into your expertise field. For us, it's architecture. So then I think having the fundamental of, like, let's say, calculus, the idea of linear algebra, it actually helps a lot in terms of your interpretation, understanding of 3D modeling, because it's all about describing geometries in a technical form. Even though we have this visual programming platform that offers like Grasshopper, but there's always a limitation in terms of tools. And if you want to do something that is more intricate, more complex, and have more control of what you want to do, then having a great fundamental skills in math and science, I think that helps a lot. And perhaps that actually gives you a lot of opportunity. And it gives you a lot of opportunity and freedom in terms of technical skills that I think will be beneficial as a graduate from SUTD in that sense.
So I just build on that. Over this time working in Airlab, Anna, has been approached by industry people that were actually, wow, we would love to have someone like you in our office, because the skills that you get here are very unique, are very distinctive from other universities. So when they find SUTD students that are actually they have developed this path, this complexity of thinking and addressing the problems in such a precise way, an informed way, which is what we do. We use digital tools, but it's not because we love just software per se, because we can use tools to address the questions in a more complex and deeper way. And then industry actually loves that. When they find someone that really can do that, they really want to incorporate that person in the team. So I would say that opportunities are there. Of course, you can follow different paths. In SUTD, we prepare you for you to choose. You actually can follow more path into academia. You can do a PhD. You can go deeper in your research, but also you can really go fully into practice. And then we have successful students that are now in the top, architectural firms right now, and it's very rewarding that they're really performing very well, and they're really appreciating the team.
And I think just to add on a little bit, as we are moving towards the future of architecture, we are no longer tapped with the tradition of doing just floor plans and sketching. There are a lot more that is required in terms of skill sets that we need to design, how to manufacturing the parts, and how can we design a system that could adapt to different conditions and requirements based on the client needs. For example, Thomas talked about adapting to the shading, the sun, the sun performance required, and in our case, it's structural components. So I think all this a little bit of overlap into, or at least expanding not just pure aesthetic, but adapting technologies in engineering aspects. I think that actually helped, and I think that makes us actually stand out more.
Would Prof Thomas and Daniel would like to answer this question, or?
To add to what has been said already, I think it's really the kind of multidisciplinary approach to design that we have here at SUTD that sets the university apart. To be fair, I would say more and more traditional universities do the same thing. I think a lot of places now try to organize their curriculum in a similar way, but if you have a choice, you go to the original, right, which is, I would say, in Singapore context, is still SUTD. So it is things like were described by Carlos, but it's also experiences like the capstone, right, that really set our graduates apart. And I think statistically, our students have done better than their peers from the other, in this case, we're talking architecture, right? So there's only one other university in Singapore that offers a Master of Architecture. which is also a great institution, certainly. But I think, you know, it seems our students have a little bit an edge over them. Generally speaking, I'm not worried that, you know, as you graduate from architecture and sustainable design at SUTD or maybe also other universities, that you will have a problem finding a job. I mean, just look around how much construction is done. And the beautiful thing generally, that is not just something that applies to SUTD, but generally to architecture training. With architecture training, you can go into so many different fields. I mean, you can go into real estate development if that's your thing. You can become a boutique architect, right? You can become a researcher with Air Lab. You know, so it's a really a wide spectrum of things that you can do. And in fact, many people also go in very different directions because of, you know, the base that you get in architecture training. So I can personally share, I never regretted choosing this field. I'm so happy still that I'm in this when I see what some of my peers are doing. So for me, this is still, you know, in a way, a dream profession. I don't know, Daniel, you want to say something?
Course, yeah. And, you know, no regrets. And going on through the entire system, I think it gives us a very holistic perspective of many things in life, you know, not just in career, but in a way in which we approach problems and deal with things in which issues with you know, other people and with organizations and with systems. Yeah, I think it gives us very well-rounded and holistic way of considering all these. And and I think this kind of design, architectural, and even computational sort of thinking that we have from this education really gives us that sort of an advantage, even in other within as a consultant within other organizations, like, you know, be they private or governmental.
Okay, thank you. So anyone here would like to ask any question regarding anything that hasn't been addressed yet? If not, we'll move on to another question by another participant. So Jin Tse has asked, in the outside world, do people work more in teams? And if yes, does SUTD place more emphasis on team-created works? So anyone from the panel may answer this question.
Yeah, I take this. Yes, I mean, I think a lot of the things that we have said already stress that point, right? Teamwork is absolutely critical for your career in SUTD. I mean, that's also how we choose students. We believe that we want students that are actually able to communicate about what they do and work effectively in teams. I mean, in teams, there are many roles. You can be a leader, you can be a contributor, and so on. And that is all possible. But yes, there is a lot of emphasis on teamwork in SUTD. And as I mentioned previously, this is clearly something that sets our graduates apart from the graduates of other universities.
Okay, thank you. Would Prof Carlos like to add more regarding?
Yes, maybe. I mean, what Thomas said. I mean, we build that culture in the curriculum, not just. I mean, in the project I've seen here, the research that we do with our team, but also in the studios, right? In the GESSM, of course. GESSM is multidisciplinary, is like cross-pillar, and in the studios, we actually work also with teams of 3-5 students working together into a project. So we actually expose you to different conditions. At the beginning, the core studio, you work more in individual projects, and then you start working together as you move forward in the curriculum in the option studios. So you get exposed to working and to really experience the group dynamics, which is something you guys will experience when you are like working in a firm or working in a team. You need to actually to take someone else's idea as yours and to put it like as to the next level. I mean, you can contribute to that idea in a way that you internalize and you can actually make it better, or you can propose new ideas. So it's group dynamics are very important for us, and it's actually how we design. It's not is no longer the image of the architect sitting in a desk and try to find that bright idea. It's no longer that. It's like way more connected. We need to learn how to work remotely. So this year we have applied technology like platforms that actually allows us to work remotely. We necessarily don't need to share the physical space. So we explore new platforms like Miro, and students are super excited about working with that platform that allows students working in different places. So in SUTD, we are somehow pioneers of introducing those technologies and to experiment with new group dynamics.
Okay. Whether it's asked to pursue Masters of Architecture after graduating, and also another question asks if they graduate from the Masters of Architecture program, is it possible for him to work back to the engineering industry? So maybe Anna could answer this question since you took the Masters of Architecture.
Well, I mean, I will encourage you to do a master's because master's, during undergrad years are the years where you got all the skills and knowledge. During master's years, the difference is actually doing what you want to do, something that you want to investigate by spending a year experimenting and discovering just one question that you have that you would like to answer in that year. Whether it's it a must, I think it really depends on individual interests. But now I say, I would encourage. I personally enjoyed it, even though it's not easy, but it's fulfilling. Yeah.
And also
Can I just add to this? I mean, the question of if the question is, should you do the master or not? I think there's another important aspect to this, which is the master is actually required for your professional accreditation, right, as an architect. So in other words, you can only become a full-blown architect who signs off on drawing, everything, submit essentially to the agencies if you have a Master of Architecture degree, and this is a worldwide kind of requirement, right? So the way this works is you get your master and then you have to work for a minimum of 2 years, after which you can apply with the Board of Architects for registration as an architect, and only then can you call yourself in the Singapore context an architect. If you have a bachelor's degree in architecture, you are not an architect. I just want to be very clear on this now.
Okay, thank you for the clarification. So there's another question going from that, is that after he graduates from Master in Architecture, would it be possible for him to venture into another career, for instance, in engineering? So anyone on the panel can answer that question.
I think there are many offices. I mean, you take an office like Over Arab, right, which operates kind of at the threshold of engineering, architectural design, sustainable design, and so on, where clearly you can have a career there when you come from SUTD in particular, because we are operating as an institution on that threshold ourselves. So I would say when it comes to the actual projects, those things have become much more fluid, right? So it's no longer that we design something as architects and then we hand it over to a structural engineer who has to make this stand up. So that's certainly a thing of the past. So if you take a project like the Future of Us as an example, we were, as architects, we were involved. In fact, we did the structure for this. It was only signed off by a structural engineer, and vice versa. The structural engineer was also involved in what we did. So I think this environment has become a lot more fluid. Nevertheless, I think there is a distinction still, and it's not when you have registered as an architect, all of a sudden you can call yourself structural engineer. It doesn't work like this in terms of legal arrangements. So there are certain implications that come with the profession that you're officially in, but in practice, I would say it has become very, very fluid.
Okay, thank you. So does anyone from Studio have a question? Would they like to ask a question from Studio 4?
No physical questions here.
If there's no physical question, there's an online question for Prof Thomas. So were there any elements or structural elements that need to be changed in order to convert the pavilion to be permanent?
Oh, that's a good question. So if you remember in the presentation, I said the project was originally meant to stand only for 3 months, right, for the duration of the Future of Us exhibition in 2015, early 2016. So when the government then decided, and it had a permit only for 6 months, right, which is a temporary building permit from the respective government agency. So when the government, the Singapore government, decided to keep it as a permanent structure, in fact, what needed to be done is all the panels, the triangles, had to be taken off the primary steel structure. And it's not that it can't stand, but it's the way the steel was treated. So because there was tremendous time pressure to get it done, it was treated in a way that would not have been permanent. So the only way to get to the steel was to take off the cladding, treat the steel, and then put the triangles back on, also in a different way. So before it was done in a very quick kind of almost like a clamp, right? You just plug it in there, and that had to be, so is a minor detail, but of course a detail. If you remember, it has 10,000 of those triangles that had to replace on 3 sides of each one of these. So these were the 2 adjustments that had to be made. I guess we were lucky because it was in a way a Singapore government project, so we didn't have to fight all the budget fights that typically come with a project like this. And I'm sure you know, the Singapore government actually has quite deep pockets. So in this case, no issue. They just did it, and it was done within a month. And it is what it is now. But very good question.
Okay, thank you. So there's another question for everyone on the panel. So how are these computer-generated designs manifested, and how can they be evaluated to be feasible constructs of our econ? So anyone can take this question.
I think Carlos and Anna spoke quite a bit about this, right? I mean, they showed how, in a way, you start with a conceptual idea that is not usually generated by the computer. I mean, your idea and judgment has to come from somewhere. But once you have that idea, you can, of course, use the digital tools to develop this. So maybe I jump to our project. I mean, I explained generally the idea that we were after with this, but we had to then translate this into, in a way, a mathematical formula that would allow for parametric design to happen. So you develop this first as an idea, then in 2D, then ultimately it becomes more complex as you translate this into a 3D structure, and especially it becomes more complex when you scale this up. So, but it's a very kind of a continuous process where the computational tool, of course, helps a lot to go all these steps. So the computational model lets you then simulate a lot of things before you go on site. It lets you generate, in our case, the cut sheets for the aluminum panels. And then this information that is generated on the 3D model is then fed into a machine. The machine knows, it has a so-called tool path along which it cuts these panels. And the amazing thing is that these things are absolutely precise, right? So, I mean, you can imagine in a project like the air mesh or, ours, it has to fit, right? There is no room for tolerance. And the precision that these digital tools allow for is just unprecedented in building construction. So I think that one is truly amazing. And the fact, of course, as an architect, you can see this through from conception all the way to the manufacturing of the parts and assembly. So I hope that answers the question.
Okay, thank you. Prof Carlos or Anna, anything to add on?
Yeah, I mean, yes, digital tools offer a lot of possibilities for architecture, right? I mean, tolerances, precision, accuracy, complexity, and also we can use them in combination with design intuition that we have. I mean, we can actually you will still sketch, right? We still draw ideas in a very simple manner. We still need to draw, we need to do some model making. So still things that, pertain to the architectural discipline still are here in between us. It's not replaced by the computer, but we use computer at different stages of the design. Maybe at the beginning, when we sketch, we also need to sketch in 3D, and then we do a quick 3D model, like wireframe model. So at different stages of design, tools become relevant in different ways. And definitely when it comes to the development and the construction are nowadays really, changing the game that we build, right, and we execute things. So in SUTD we actually expose you to the different stages of using technology. At the beginning with the basic fundamentals and try to do some creative approaches by using it, and also at some point with more accurate exercises of how to fabricate and develop like more physical prototypes, right? So I think we try to introduce that from the very beginning, so it doesn't feel like alien to you. It's like something that you live from the beginning of your education and becomes part of your DNA as an architect, right? I think it's definitely the changes in architecture require the implementation of technology. We really are redefining the way that we teach and the way we shape education, integrating and embracing what is really relevant to us. And I think it's the feedback from the students that get graduated is good on that.
Okay, thank you.
I just add to this because I mean we have of course now today we have shown you 2 architectural projects, right? But I would say the same also applies to the larger scale of the city, right? I mean, the way we understand the city, we analyze the city, we come up with planning decisions, urban design decisions, is very much informed, through the use of digital tools, be it through analyzing data, understanding how people use spaces. I mean, there's a whole world kind of out there to explore that often architects also live in, right? Work in, do research on. In fact, in my lab currently, we're working probably much more on the urban scale than the architectural scale, because there's a whole kind of world out there that we can explore and then design better, right? Plan things better through the use of computational tools. So it's by no means limited to the architectural scale, nor do we as architects only think about the architectural scale. We also think about much bigger scales, regional scales, even planetary scales, right?
Thank you. So we have one last question from a participant online. So she asked that if she's a beginner at designing but is creative and wants to try for SUTD, what are the chances that SUTD will consider her for an interview to show her worth and passion despite not doing so well for her result? Yeah. So anyone can take that question.
I think if you have the passion, ultimately there will be a way, right? So, I mean, we don't know the case, and it's not just us who decide this. I mean, it's the whole, there's a whole administrative process to this. But if you are passionate about, then, you should give it your best. And ultimately, I believe if you have the energy and the will, you will succeed.
I think the process is not just about the grades. I think sometimes we're quite impressed when we have interviewees that bring some, maybe there are some self-initiated things that they have done, or they show the passion as well. So it's a bit like, informed from different sides. Of course, grades are important anywhere in Singapore, but it's definitely we look at something else as well. And then definitely you have the ambition to really get into SUTD. I think just, as Thomas said, just keep your motivation up and try to pursue that path.
Okay. Thank you. So we have received quite a few questions regarding the admissions to programs such as STEP or SHARP or like Duke NUS. But for these, do refer to the SUTD website for more information. We can find, or you can drop by the virtual open house to find out more about these as well. So with that, we have come to the end of the session. And thank you, panelists, for this very informative discussion with the audiences. And SUTD SD has really provided its students with many unique opportunities to showcase their skills, learn in studio, and apply it to real-life projects. So I sincerely look forward to having more exciting opportunities to come in the future. And meanwhile, please do look forward to the next event, which is the Air Bamboo workshop held by Prof Carlos himself here at 1:30 p.m. So lunch is really ready for you over there. And thank you and hope to see you again.